Hello and welcome to our Nitro Electronics channel. Today I want to tell you why a capacitor is open in a DC circuit and closed in an AC circuit, and I will also tell you about some applications of capacitors in circuits. But before that, let me demonstrate the circuit practically to you. I want to connect a 9V DC voltage source to this circuit, and when the voltage reaches the LED turns on. When a capacitor comes in the way of the LED, no current passes through the capacitor until the LED turns on. This is why we say that the capacitor is open in a DC circuit. Now, I connect a capacitor in series with a 220V lamp and connect these two probe wires to the 220V AC power. Now we can see that the lamp turns on easily, meaning that the current passes easily through the capacitor and there is no obstacle. So the capacitor acts as closed in an AC circuit. The reason for this is that when the capacitor is in an AC state, the alternating current frequency charges and discharges it, showing a resistance of its own, which depends on the frequency and the value of the capacitor itself. After 5 time constants, the capacitor is fully charged in a DC state and no longer allows any current to pass through itself, causing the LED to blink briefly during this interval. The 5 time constants are the amount of time it takes for the capacitor to fully charge. This capacitive resistance is called reactance and how it is obtained. Capacitive reactance is the opposition that a capacitor offers to alternating current AC due to its phase-shifted storage and release of energy in its electric field. It is symbolized by the capital letter X and is measured in ohms, similar to resistance, R. The formula for calculating capacitive reactance is applications of capacitors. 1. Filtering. Capacitors are commonly used to filter out unwanted signals. For instance, they can remove noise and ripple from power supplies or block DC signals, while allowing AC signals to pass through. 2. Timing. Capacitors create time delays in electronic circuits. By charging a capacitor slowly through a resistor and then discharging it rapidly, we can introduce controlled time delays. 3. Coupling. Capacitors couple two stages of an amplifier, allowing AC signals to pass through while blocking DC signals. This technique is known as AC coupling. 4. Energy storage. Capacitors store electrical energy. They smooth out voltage fluctuations in power supplies and are used in electric vehicles to store energy from regenerative braking systems. 5. Signal processing. Capacitors tune resonance circuits and shape the frequency response in audio and radio frequency circuits. Like and subscribe to support us so we can create better quality videos for you. Goodbye.